right, sometimes it's easier to take an equation from polar to rectangular or rectangular to polar. It just depends. We are in this one are going to go on how to change one from polar to a rectangular equation. We use our same values. X is equal to r cosine theta and y is equal to r sine theta, and r squared equals x squared plus y squared. So in order to substitute, notice I would need either an r cosine theta, an r sine theta, or at least an r squared. So in order to get an r squared, there's different ways we can go about that. We can multiply both sides by r, which would give me an r squared here and a 5r here. But then notice I would have a 5r, and that would not help me out either. So rather than that, the other way to get an r squared on this side would be to square both sides of the equation. So that's what I'm going to do. I'm going to square both sides of the equation. And then I have r squared equals 25. Now I can substitute because I know that r squared is x squared plus y squared. So I just substitute and replace my r squared with an x squared plus y squared. And I get x squared plus y squared equals 25. Okay, now it has been converted to rectangular because there are no r's, there are no thetas. Everything is in terms of x, y, and numbers, and real numbers. Okay, so there's just a few tricks to this. What happens if you have theta equals 3 pi over 4? Now that doesn't fit with any of the things that I knew over here. We do have one more thing that we used when we were converting, and that was that tangent of theta is equal to y over x. Okay, so no, I don't have a tangent theta, but something I can do here is take the tangent of both sides. Okay, so then I would have the tangent of theta is equal to the tangent of 3 pi over 4. And now I can substitute. Okay, it's okay to just take the tangent of both sides. On this side, I know that tangent theta is equivalent to y over x. Okay, over here, I just do the tangent of 3 pi over 4. The tangent of 3 pi over 4 is -1. I want to simplify this a little bit. Again, depending on your text or your instructor, they may want it in a different way, but I think that it would be simplest to just multiply both sides by x, and then I get y equals -x, which is a way we typically see a rectangular equation. Very seldom do we see it written like this. So taking that one more step is probably necessary, and our simplified version would be y equals -x. It's in slope-intercept form. Here we have r plus r cosine theta equals 3. Okay, so again, we want to decide, well, what do we need to do? We want to get rid of all the r's, we want to get rid of that cosine theta, and we want to just have x's and y's. Well, again, we have this issue of we just have a plain r, so we need to either have it be an r squared, or we need to have a cosine somewhere. If I tried to multiply everything by cosine or sine, then I would get a mixture here and wouldn't have the r that I need. So instead, when I have something like this, I could square both sides of the equation. But before that, I probably want to go ahead and subtract this r cosine theta to the other side. Okay, so again, my option to end up with an r squared was either to multiply everything by r or just to square r. So I'm going to get r by itself first because multiplying by r was not a good option. It would give me a 3r here, which just wouldn't work. So instead I'm getting r by itself, and then I'm going to square both sides. Okay, that gives me r squared on the left side. On the right side, be careful. I'm going to write this out because a lot of times people forget that squaring a binomial means you're actually multiplying it by itself. Okay, so I'm writing this out and foiling it. 3 times 3 is 9, and 3 times -r cosine theta is -3r cosine theta. And then we take this times everything in that second set. r times r gives me r squared, and cosine times cosine gives me cosine squared. Okay, and then over here I still have that r squared. Well, let's simplify a little bit. So I do have these like terms I can add together. -3 and -3 gives me a -6r cosine theta, and then on the end I have r squared cosine squared theta. Okay, so now I can substitute because everything is either an r squared or has an r cosine r sine with it. Up here we were not okay because that was just an r by itself. I know r squared is equivalent to x squared plus y squared, okay, from my shortcuts there. So I substitute 9 minus 6 r cosine theta is equal to x, so that's a 6x. And what about this r squared cosine squared? Well, notice if I square here and here and here, I know x squared is r squared cosine squared theta. So this is the same as x squared. Let's do a little simplifying. Notice I have x squared on both sides, so if I subtract x squared, they actually end up canceling in this case, and I'm left with y squared equals 9 minus 6x. And that's probably the way I would just leave it. You might want to put the -6x first, but we have successfully removed all r's and thetas, and we have just x's and y's. All right, here's our next example. R is equal to cosine theta minus sine theta. All right, well, again, we have just a plain r, which is a problem. We have another problem. We have just a cosine theta and a sine theta. And notice in our conversions here, we need an r cosine theta and an r sine theta and an r squared. So remember, to get an r squared, we could either square both sides or we could multiply by r on both sides. Now this time we don't want to square. The reason is that wouldn't solve our problem on this side. But if we multiply everything by r, that does solve our problem on both sides. Because on the left side I end up with r squared, and on the right side I end up with r cosine theta minus r sine theta. So it fixed both problems. I now have my r squared, and now I have an r with my cosine theta and my sine theta. So I just used the property of algebra that it's okay to multiply both sides by the same thing, and that fixed it up. Now I can do my substituting. So r squared is equal to x squared plus y squared. So I have x squared plus y squared here. R cosine theta is x. R sine theta is y. So I get x squared plus y squared equals x minus y. And again, depending on your text or your teacher, they may want you to move those to the other side. So you have x squared plus y squared minus x plus y equals 0. But I would take either of those. All right, here's one last example. We want to convert r equals 2 over 1 minus sine theta. We want to convert that to a rectangular equation. Okay. Well, the first thing I notice is that I do have the problem. I have just a plain r here. I also have the problem that there's no r with my sine. I also have a fraction. The first thing I'm going to do here is get rid of that fraction by multiplying by the denominator. We'll cancel it here, and on this side, you have to do it on both sides if you're going to multiply. Okay, so I get just 2 over here, and here if I distribute, I get r minus r sine theta. So that has actually solved one of my issues. I now have an r with my sine, which is what I need for my conversion. But I still have the problem that I have an r that's not squared. For my substituting, I need an r squared. Okay, so again, our options to get an r squared were either to take everything times an r or to square both sides. Now notice if I take everything times an r, that will leave me with a 2r here. It would, which is a problem. It would also leave me with an r squared sine theta, which is a problem. R squared sine squared is fine, but just plain r squared sine wouldn't work out very well. Okay, so what we're going to do then is we are going to square both sides of the But before we do that, something we want to do is we want to just get this r by itself so that we make sure we end up with an r squared over here. So I'm going to go ahead and add r sine theta to both sides so that I can get ready to do my squaring. So that gives me r equals 2 plus r sine theta. Somehow, hold on just a second, let me erase wherever that 2 came from, probably from a previous problem. Okay. All right, so now we're all set up and ready to go. Now I have my r here, I'm going to square, which means I also have to square this side. It gives me r squared equals 2 plus r sine theta, and forgive me for writing it out, but lots of times people forget to do this. They just square the first part and square the second part, and that messes them up. You are actually kind of foiling this out. So 2 times 2 is 4. 2 times r sine theta is 2r sine theta. Same here, 2r sine theta. And r squared sine squared theta. All right, so now let's simplify a little bit. Notice I have a like terms here. I have a 2r sine theta and a 2r sine theta. That gives me 4 plus 4r sine theta plus r squared sine squared theta. Okay, let's do our substituting. Let's make sure we can. Do we know something for r squared? We do. R squared is equal to x squared plus y squared. Over here, we have our 4 plus 4 r sine theta, remember, is equal to y, so we have 4y, plus, and remember, r squared sine squared, as long as they're both squared, that's the same as y squared. Okay, so replace that with a y squared. All right, let's bring everything to the same side. So here's my y squared. If I subtract from both sides, they cancel. I'm going to subtract 4 from both sides, and I'm going to subtract the 4y from both sides. Sorry, that got a little ugly because I ran out of room. But I end up with x squared minus 4y minus 4 is equal to 0. You may also probably write the answer as just x squared equals 4y plus, 4 plus 4y. Okay, and again, it just depends on the text, on what they consider to be simplified and what they consider to be standard form of different functions. But either of those really can work out. Okay, so those are some of the tricks of converting from